is Professor Pelton. This is part 2 of Chapter 5, Section 3. We're going to now look at what if you have multiple of the same x-intercept when you calculate, or multiple of the same 0, which is the same thing. Well, it comes down to what we saw in the very first problem. For the most part, they pass through the graph unless it happens an even number of times, which is what happened with the 0 or the origin intercept that we got on the prior page, because it happened twice. What happened is it bounced off the graph. It touches the graph and bounces off at the x-axis. If it's an odd number of times and it passes through the graph, in each case, right, it's going to pass through in a polynomial type manner. So if it happens once, it's linear. It'll pass through linear. If it's a quadratic, which is second power, it'll bounce off in a quadratic manner. If it's third power, it'll pass through in a cubic type form. And that repeats itself as you increase, as you go up through the types of polynomials. Okay, so let's try an example down here. So if I took this problem here and multiplied it all out, you don't need to, it's kind of irrelevant. But first off, if I just did the math in my head, if I squared, come on, come on. Okay, so if I squared this, I get 4x squared times 1 more x is 4x to the third times 1/2, if you think about it, is 2x to the third, correct? Plus dot, dot, dot. The remaining terms don't matter. All we need is the leading term. That's it, right? So if you want to spend the time to multiply it all out, you can, right? So multiply it all out. You get 2x to the third, and the remaining terms are irrelevant because those don't determine end behavior, right? So 2x to the third is the leading term. That's what we're going to go with, okay? Okay, so this is 2x to the third plus dot, dot, dot. The rest is irrelevant, okay? So I've already done the work to factor the problem for you. Unlike in the prior problems, we had to do the factoring first. So 1/2 equals 0, x plus 1 equals 0, and 2x minus 3 equals 0. So that's not true. So we'll minus 1, x equals -1, add 3, 2x equals 3, or x equals 3/2 when we divide. Okay, so essentially what we get is the x-intercepts, which are -1, 0, and 3/2, 0. And then y-intercepts, we get 0, comma, something. So we plug that in. We're going to get y equals 1/2. Let's see, 0 plus 1, or 2 times 0 minus 3 squared. So y equals 1/2 times 1 times, let's see, that'd be 9 when I square it. So that's 4.5. Okay, so put those in the graph. So we're at -1, we're at 1.5, and we're at 4.5. Now we need to analyze end behavior. So end behavior. Okay, so I only need to look at the 2x to the third power. So as x approaches negative infinity, and as x approaches positive infinity, what happens to the function? So the positive 2 does nothing. Multiplying by a positive number doesn't change anything. But the x to the third power keeps a negative negative and keeps a positive positive, right? So you do a third power of a negative, you get a negative, third power of a positive, you get a positive. So the end behavior is in the positive direction, I go up, in the negative direction, I go down. Okay, so you make a graph going left to right. So I'm going to go up to the first point, and -1 only happens once. So I'm going to go through that point, and then I'm going to go down to this one. But this one happens twice, which is even. So I'm going to bounce off in a quadratic manner because second power is quadratic. So even, I go through the axis. Sorry, odd, I go through the axis. Even, I bounce off the axis, and I do so in a manner that is consistent with the number of times it repeats. So since it's linear, I really need to smooth this out a little bit more. It really should pass through in a linear type manner. Okay. All right, pause the video. Try the student problem for yourself. Okay, so again, you can multiply this all out if you want to. And if I do that, I'm going to get x squared for this one. I'm going to get 2x for this one and negative 2 for this one. So if I multiply that out, I get negative 4x to the third plus dot, 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 a series of terms afterwards, which are irrelevant in the graphing situation. So I've already done the hard part of factoring the problem out for you. All right, so negative 2 is equal to 0. X minus 2 is equal to 0. And 2x plus 3 is equal to 0. So obviously the first one's not valid. So x is equal to 2. 2x is equal to negative 3, or x is equal to negative 3 halves. Okay, so my x-intercepts are 2, 0, and negative 3 halves 0. And then my y-intercept, I have a 0 for the x by definition and the location. So you have y equals negative 2 times 0 minus 2 squared times 2 times 0 plus 3. That's the first power, right? So we get y equals negative 2 times 4, because you square it, it becomes positive, times 3. So that gives me negative 24. Okay, so I'm at 2, 0. So 1, 2, we'll put a point. And then at 1, 2, halfway between is 1.5. And then negative 24, we'll just make a random point down here. So this is 0, comma, negative 24. All right, now we need to analyze end behavior. All right, so end behavior. Okay. So our term is negative 4x to the third, right? So as x approaches negative infinity and x approaches positive infinity, the function does what? That's the end behavior. Okay, so in both cases, the third power doesn't do anything, right? If I plug in a negative to the third power, it stays negative. If I plug a positive into the third power, it stays positive. However, if I multiply by a negative afterwards, following the order of operations, it switches it. So that goes to positive infinity, that goes to negative infinity, right? That's our end behavior. So in the positive direction, I'm going to go down. In the negative direction, I'm going to go up, right? Because I'm doing x negative and x positive as far as the directions. Okay, so if I make the graph here, I'm going to move this over a little bit. I'm going to come down to this point, and that is x to the negative 3 halves. That only happens once. I'm going to pass through it in a linear manner. I'm going to come up to this point. This one happens twice. That means I'm going to bounce off since that's even. I'm going to do it in a quadratic manner. So it looks like a quadratic. You don't need this little piece over there. Okay. All right. Let's go to the next page and analyze some ones that have even higher powers. Okay. So if I multiply this one all out, that'll give me x to the third power. That'll give me x squared. That'll give me x, and that'll give me 2, right? So if I multiply all that, I get 2x to the sixth power plus a whole bunch of terms afterwards, which we don't care about, right? Again, you can do the math if you want, but it's kind of silly to do so. Unless the problem specifically asks for the general form, then you would have to multiply that all out. So 2 does not equal 0. X plus 3 is equal to 0. X minus 2 is equal to 0. And x plus 1 is equal to 0. To be clear, a lot of the times they give them the general form. You'll have to do the factor and get it down to like this, but to save time, I've already done the factoring for you. Okay, so x equals negative 3, x equals 2, and x equals negative 1. So I think we're good there. Okay, so my x-intercepts are negative 3, 0, 2, 0, and negative 1, 0. So y-intercept is 0, comma something, right? The x is 0. So y equals 2 times 0 plus 3 times 0 minus 2 squared, and then 0 plus 1 to the third. So that gives me 2 times 3 times 4 times 1. So that's what, 6 times 4, so we get 24. Okay. All right, so we have negative 3, 0, 1, 2, 3. We have 2, 0, negative 1, 0. And up here, we'll just put a random 24, right? So 0, comma 24. is that. So we have x in the positive direction and x in the negative direction. What is the end behavior, right? So end behavior. So x goes in the negative direction and x goes in the positive direction. What happens to the function in the end? So f is approaching what? The function is approaching what? So we're only looking at 2 times x to the 6th power. Okay, so obviously you plug this into here for the end behavior, right? The times 2 is not going to change anything. Anything times a positive number is whatever it is. So x to the 6th power, that's going to make that a positive, and the positive stays a positive. So my end behavior is essentially up, up. So in the negative direction, I'm going up. In the positive direction, I'm going up. Okay, so draw a graph left to right. So I'm going to go down to the first point. So that is -3, which happens only once. So I'm going to go through the graph. Go back up to -1, which happens 3 times. So that's cubic. So I need to go through this point in a cubic type manner. So what I'm going to do, since I went to the first one a linear type manner, I need to do this one cubically. So cubically, I'm going to go like this, right? Because remember, a cubic function looks like this, right? That's what a third power function looks like. Okay, so now I'm going to come down to this point here, which is which is x equals 2, which happens twice, right? That's an even number of times. Therefore, it has to bounce off of the axis in a quadratic manner and come up, right? So for odds go through the graph, evens bounce off the graph, and they need to do so in the correct visual for what they are. So a line is first power, right? X is first power. That's cubic, and then of course quadratic is second power. So you need to visually look like that. Okay, pause the video, try the next problem for yourself. Okay, so the next one, if you multiply it all out, you're going to get x times x to the third times x to the second times -1/8. So that's -1/8 x to the sixth plus dot dot dot, some more terms afterwards, which are relevant for end behavior, right? So -1/8 is equal to 0. X plus 1 is equal to 0. X minus 2 is equal to 0. And x minus 4 is equal to 0. So that one's not true. So x is -1. So x is 2. And x is 4. Just to reiterate, it's not necessary to multiply it all out to get to general form. And if it was in general form, you'd have to do the work to factor it all out like we did in the first page. Okay. All right. So my x-intercepts are -1, 0, 2, 0, and 4, 0. Okay. And my y-intercept is 0, comma something. So y equals -1/8 times 0 plus 1 squared, 0 minus 2 to the third, and 0 minus 4. That's the first power, right? So I have y equals -1/8 times 1 times -8 times -4, right? So the 1/8 and the 8 cancel out, so I'm just left with a -4. Okay, so 1, 2, 3, 4, close enough. 1, 2, 3, 4, close enough. We're also at 2. We're also at -1. All right, now we need to analyze the end behavior. So end behavior. Okay, so we only need to analyze the leading term, which in this case is -1/8 x to the 6th power. So as x goes in the negative direction and as x goes in the positive direction, the function goes in what direction? The function goes into. Well, if I plug in a negative to the 6th power, it becomes positive. Then I times it by a -1/8, it becomes a negative. I plug a positive infinity into 1/6, I get a positive, times -1/8 is a negative. So in this one, it goes both down. And you should understand from the prior section that even functions either both go down or both go up, and odd functions go in opposite directions, up, down, or down, up, as far as end behavior goes. Okay, so I'm going to start left to right. And I'm going to go up to the first point, which is -1. And -1 happens twice, which is an even number of times, and it's quadratic. So I'm going to bounce off in a quadratic fashion, go to the next point, up to the next one. which is 2. 2 happens 3 times. So that means I need to pass through it since it's odd, and since it's 3, I need to do so in a cubic manner. So if I do it in a cubic manner, I'm not doing, hold on, my arch skills aren't that great. Let me try that again. I think I need to come more of an angle at it. There we go. That's a cubic manner. All right, we'll go up and come back down to this one, which is 4. 4 is 1. That's a linear. So just go through it in a linear manner. So odds, you pass through. In evens, we bounce off the x-axis. Okay, that is the end of part 2.